Okay, welcome back. So in my previous video, I ran a little bit too much current through this Agilent Shunt. So I want to test it. I want to test it on the low end, I want to test it on the high end, and we'll see where we're at. So let me tell you what I got going on here. I have, in a crazy way, these two power supplies are tied together in parallel. These are tied together internally in parallel. These are individually wired in parallel. And then all three of these power supplies actually, if you count that as 2, 2, and 3, that would be 7 power supplies, all wired together with the DC load set up ready to pull 30 amps. We have 10.2 amps here, 10.2 amps here, and we have 3.2 times 3. So that would be 9.6. That should give me enough to pull 30 on the DC load. This will go up to 60 amps, 120 volts, 250 watts total load. This is the BK Precision 8601. We have the shunt tied in here. We do not have a backlight on this because it gave me a low battery, so it disabled my backlight. We have the Fluke 376 FC sitting here, zeroed out, ready to go, as well as the Uni-T UT211B. Stupidly, I got a metal coffee cup in the background here around a bunch of lithium cells on a bench. I never said I was the smartest person. Let's turn them all on and see what happens. I'm hoping we get 30 amps and it agrees here and here. Only one way to find out. So we got a all on channel here, but I have to hit OK. And these two I can actually reach across and turn them both on at the same time. So that's important if you don't want to damage your power supplies. Okay, we seem to be running on all of them now. And let's give it a 30 amp load. I'm gonna turn on mid-max here. I forgot to do that. Mid-max there. And this has a hold. We'll hold this one, okay. So everything seems to agree here. That is magnificent. That is really, really good. Actually, I said these were running at 5 volts, so I'm wrong. These are running at 5.5 volts, all of the 7 power supplies. Or 3, depending on how you look at it. So, results. Slightly one wire. I'm afraid to turn the light on because I don't want to screw up the results on it. Let's just bring it to the camera. So we got 30.2 amps over here. This one I had facing the wrong direction, but you get the point. 29.46 amps here. And across the shunt, if it will focus without light reflection, I don't know if you can see that. Well, it's 30.009. So it looks like my shunt is still running and still doing good with the 30 amp. Of course, I haven't ran it for 15 minutes. I don't want to do that because, well, the power supplies, basically. I don't want to run them that long, all tied together in parallel like that. Technically, I don't think Rigel, this is the DP832, I don't believe they support putting their power supplies in parallel like that, which was one of my concerns. But let's go ahead and all off these. Okay, so now we're all down. So we need to test the low current. That requires rewiring, and we don't need all these wires because this was a lot to wire up. I'm kind of be ashamed to take them down now. So the other one was feeding from the top 4 power supplies on the positive rail down to the parallel input of the first power supply on the Rigel. The green one was feeding from these 4 power supplies on the negative side, on the output side, down to the negative on the last power supply in parallel on the Rigel. So that's how these connected to there. These two internally, they have a relay. You can put it in parallel mode, and the same thing with this, you can put them in parallel mode. I'm going to take those out right now. Shut that off. And shut that off. And then just connecting the two of these together, of course, simplistic, easy to define. This one is my remote sense. This was the remote sense for the DC load, for the voltage, and I believe I had the remote sense feeding out on the negative side down here on these fails. It says I'm drawing 76, 76, 76. Okay, I'd say it's still good on the low end too. If I bring it down, let's get it to draw 10 milliamps. That's what I need. Drawing 10 milliamps, the clamp says 9, the shunt says 9, this says 10, that says it's pulling 7. I wouldn't trust that, honestly. See if I can get it to draw 5 milliamps. 5. Well, 4 and 5 flickering, 5, and this says 5. That's great. 3. Load says 3. This says 3, flickering 2. The clamp says 3. Down to 1 milliamp. This actually says 1. Whoop, nope, now it says 0. It's flickering 1. It's teetering. This says 2. Okay, I'm kind of being ridiculous here down that far though. Alright, so if I put it to 2, this says 1, this says 2, that says 2, that says it's not putting out any power at all. So, all in all, I think we're okay. I don't think we did any damage. If I set this exactly to 100 milliamps here, 100 milliamp load, drawn, 99, 99 flicker on 100, 96. Yeah, I think we're good. So the shunt lower accuracy seems to be good, higher accuracy seems to be good. I believe my shunt survives that little battery load test that I was running. This still never fails to amaze me on its lower range accuracy. It really is an amazing little clamp. And on the higher end, I've never had any problems with this. Okay, turn off meters and turn off power supplies.
Sure, turning the meters off. Got it, turning off the power supplies.
And with that, I believe I'm done. Be safe, keep on tinkering. Thanks for watching, and I'll see you in the next video.